Okay, so now that we have created, we are ready with the geometry. And what we'll do is, we'll be needing boundaries to name. Okay, so whenever we run any kind of geometry, we need to have faces marked. Yeah, we'll be marking surfaces with the respective names. So what we will doing is, we'll just go here. So all of our work, I hope, is finished here. We have set the geometry kernel. We have, yeah, we have used all the basic shapes. We till now we didn't go for the transformation, not extrusion, no boolean. So these kind of operations we didn't do currently. We are just going ahead with the simpler geometries using basic shapes. Points, then lines, then surfaces, then volumes. So then here it is something called as physical groups. We'll go for adding surfaces. Okay, we'll add surface. So this is in the xy plane. Okay, positive xy plane. This is the front surface. Yeah. Oh, I should write it small. This is the front surface. E, then back surface. This one. E, then left surface. This one. Then right, right. Then top. Then bottom. Okay. And last thing is volume. So what we do is, we define a volume. We'll name it as one volume. You can have volume, or let's say volume 1. Any name should suffice. We'll just write volume. This is the volume. E. Okay. Now we'll just have a look at the script. So we have previously seen that our script updates in the real time here. If all of the operations have been captured or not, we'll just have a look at it. So I define the number, then these are 8 points, then we have drawn the lines, line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then curve loop and the plane surface are the single parts. Okay. You have a curve loop and you define a surface. So this is a single unit. Okay. Similarly, curve loop 2, plane surface 2, loop 3, surface 3, loop 4, surface 4, 5, 6. There are 6 surfaces for the cube. Okay. And then, because you have looped the curve to define the surfaces, now you loop the surfaces to define the volume. So with the same logic, you are having this volume 1 defined already, and then for your convenience, for the simulation purpose, you have followed this thing. Okay. And you can edit here. Let's say if I just want to make this v small, I prefer to write everything is small to avoid any kind of confusion. So this is the volume. Okay, so everything is here. We just save it off. If you want to change a kind of parameter, we will see how to make a change in simple terms. So this is the geometry and it is ready to be exported. Not ready to be exported. It is just a geometry. The meshing part is still missing. So we just minimize this one. Now let's go to the mesh. Okay, 1D, 2D. Okay, very bad looking, right? This is not a mesh should look like. So what we will do is, just try refining. So there is something called as refining here at the bottom. Right? Where is it? Refine by splitting it is called. Okay. Sufficiently large number of grid points, but unstructured grid. And is open form simulations can be run can be made to run using such kind of mesh. But normally we prefer structured mesh as and when possible to have faster computations. So I'll just remove it. I hope you must have seen it. So again, mesh 1D, 2D, 3D, and then refine by splitting. So that way you can have a refined mesh. Okay, but it is unstructured. Now that your geometry is ready, what we can do is just reset a viewport again. Oh, sorry. Reset a viewport again. and let's define the parameters. Okay, so let's go to edit script. In the edit script we have defined this LC. Just remove everything of this. Now I'm removing the parameter. Any other any other location wherein we have used this LC? Fine. No, there is no LC now. So you are having 8 points with the location specified. So before jumping to the mesh, what I will do is I will try defining all of the this thing, all of the numbers in terms of variables, so that we get a control panel at the top. Let's see how it looks like. So x may you can have 1. I'm defining y equal to 1, and I'm defining z is equal to, let's say, 0.5. Now I can replace all of these with x, y, this will be y, this will be again, this should be x. Similarly, you can have x, you can have y. Here also you can have y, and then x. Now everywhere you can have z here. Okay, everywhere you are having this z here. So it is x, y, and z. Now accordingly you are having this lines and then curves and then surfaces and then the physical surfaces. Okay, I'm just closing it off. Let's see. Reload the script. Reloading the script. It is loading without any kind of errors here. Please have a look here. This is the okay done reading. It says done reading without any kind of errors. So for any kind of errors, please have a look at the bottommost panel. It will pop up any kind of red description for any kind of error. So we can have a look at that, and again, okay, you have defined the variables. Now let's play around with it. How defining the variables can help us. So let's say if I want to make it point 2, the gap between the two surfaces, this front and the back surfaces, I need to reduce it. So I've defined the two, and then I'm closing it, and then reload the script. Yeah, we can see the gap has been reduced significantly. Yeah. And now domain size is this, defined by the boundaries of the blue lines. And then you can again have meshes, let's say 1D, 2D, and 3D, and then refine further, refine by splitting. Okay, this is how it looks like. Now our target was to have a structured mesh. So how will we be doing that? Now similarly, we will be defining more parameters as we have defined for x and y. Let's say you define a number of data points. Okay, I will just write it n. So let n be 20. Okay, this n will be for x and y directions. So this is the comment part. Now this nz will be equal to, let's say, around 10. You can have this is for z direction. Okay, okay. Now we have already defined the parameters. We'll just close it off and again reset viewport. Now define. There is an option in the mesh tab. It is called refine. Sorry, define. And here there is something called as transfinite, and then it is a curve. So transfinite mein you can have n number of points. Click here, 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 here. Okay. then E. The operation is still active, and we are using now NZ for these curves in the Z direction. Okay, okay, E, Q. Now that we have marked all of the grid points, all of the number of points that a segment or a line should have, we have marked that. But then that doesn't um, imply that the mesh will be structured. Let's see. Let's mesh it off. 1D, 2D. It is still unstructured, yes, because we have just defined the points on the line. The second step is to have transfinite surfaces, and we need all of the surfaces to be transfinite. So what we'll be doing is left transfinite, right transfinite, alternated. So they just defined to be, these are just kind of meshing arrangements that you can have. We will discuss it a little later. Let's see how it goes. You select one, two, E, second one E, third E, fourth, fifth E, sixth E. So our surface solar part is done. Operation is discontinued. Let's try meshing it 2D. Transfinite surfaces, we did it. And then there is this transfinite volume E. Okay. Let's try reloading the script again and then mesh 1D, 2D. There you go. Right? 3D. It should look structured. Yeah. It is now completely a structured wala mesh. Just remove the box now. Excess wala box we need to remove, and then you'll be able to see as to what we have done. Just to summarize, while we have gone through a basis in the geometry creation, we have started with a dot, then line, then surfaces, then volume. Similarly, while in the meshing, if you are trying to go for a structured mesh, you transfinite a curve, define the number of points the single curve is having, then you transfinite all the surfaces, and correspondingly transfiniting the volume will get you a structured mesh. This is how the mesh is looking. So in between we have encountered some this thing, no? Left and right and alternative. So let's have a discussion on that. Just using some parallel screens. Okay, not much use here, but still. Okay, so here we have seen something like alternated, no? Where is it? Transfinite surface 3. Okay, because it was alternated, it was nowhere written. So again, let's use again. Let's go again 1D and then reset viewport. Then you can have transfinite curve. Okay, no, not transfinite curve, transfinite surface it should be, and this is left. So let's use it, and then E. Okay. Reload the script and then 2D. Able to see it? It is left transfinite. Let's try using the right transfinite. Are we capturing this on the script? I don't know. Let's have a look. So no, it is not captured in the script. That left, right, and the transfinite algorithms are not getting captured. So this is done. We'll just cross it off and then again. So it is into the same mode. Again, we'll just try to change it into alternated. So transfinite surface, selecting a surface. Okay, marking it alternated, and then E, and then Q. Reload the script. Then 2D, then you are done. So alternated meaning you are having the both on lines, diagonally both on lines. Okay, 3D. So this is how your mesh is looking like that. And now it's time to export the mesh. I think the mesh is now complete. We have defined the boundaries. You can view it. You can view everything here. Oh my god. This is how. So tools, visibility it is called. Okay. You can view many things from here. This is a very good thing that it possesses. So we'll just try it. Let's say only we need to have a front surface. Apply it. This is the front surface. The back one, apply. Left, apply. Right, apply. Top, apply. And bottom, apply. Okay. We'll just create volume. Then everything is there. You have got this tree of everything. Then the numeric. Then the interactive. Many things. Just close it off. We just need to correct the script for now because in the last line we have written something like this, alternated. So this alternated is visible. Somehow we just close it off again, save it, and then reload, and then 3D. Directly you can jump on 3D then. Okay, reset viewport. Now we have defined everything for this geometry, and for the first tutorial it's time to export the mesh. So how you will export? File, export. This is tutorial 2. You need MSH file. So there is something called as GMSH. Obviously, you save it in terms of .go to retain the geometry. While when you want to import the file in open form, this MSH file is very important. So we'll export in MSH file. Downloads may I will use it save. Version 2 ASCII you will be needing for open form specifically. Please come to the center. Okay. It says done writing this tutorial 2. Let's have a look. Where is that tutorial? Download. Here is the MSH file. And please note that it is a very big sized file compared to the geo file. The geo file is retaining all the reading content required to construct the geometry from the scratch, while this file is the output. Okay, let's say you have deleted everything, but then you are having this file. You will be able to generate the mesh file from this one. This is the very big advantage of using GMSH. Okay, this is all for this tutorial. I hope you have liked it. In case you are having any kind of doubt, please comment or please get in touch with me for the same. So this is the basic tutorial. Just to summarize, for the geometry purpose, we have created points and then constructed the lines, then surfaces, and then defined the volume. Then we have marked the boundary. We have marked the boundary names: the top, bottom, left, right, front, and back for the box. And similarly for meshing purpose, initially it was unstructured. We have refined by splitting. While moving further, we have created the structured mesh, a fully structured mesh. Yeah, and that too we have defined the number of the grid points using transfinite algorithm. Okay, so using transfinite you define the number of points that each line is having, and that line has that number of points. Similarly, the other lines is having those many number of points you are defining, and then all connecting together will form a grid. Okay, the grid in 3D is the mesh. So this is the target mesh. Okay, the right click, with the right click you can move the geometry here and there. With the left click you can move it here and there, and then with the scroller you can go zoom in and zooming out. So these are all some basic operations for the GMSH for this tutorial. Thank you so much for your attention. Thank you so much. Bye.